Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about unconditional jumps. So jump initiation can be classified into two types. One is an unconditional jump and another one is a conditional jump. So conditional jump means it checks the condition. If the condition satisfies, it takes the jumps. If it is an unconditional jump, then no condition will be checked. So once if we have this unconditional jumps, it directly take the branches. Look at this, the different types of unconditional jumps. First one, S jump, this is a short jump. L jump, this is a long jump. This is A jump, this is absolute jump. And then jump with RTA plus DPTR. We can see each one detailing. Look at this. This is S jump. This is a short jump. It use relative addressing. So relative addressing means from the current position, so plus or minus 8-bit address. So that means it can jump from plus or minus 128. So we can forward 0 to 127 minus 128. That means from that location minus 128 location to plus 120 location, it can take a branch. So it uses the relative addressing of 8-bit. It uses this 2's complement number. So it ranges is up to 127 location. This is forward and reverse 120 minus 128. That means from that current location, so it can jump previous 128 locations. After that plus 127 locations. So it can jump plus or minus 128 locations. So the advantage of this is, so automatically, so within the loop it will be incremented, decremented, and that will be easily accessible. So relative addressing will have a best benefit. Also it have only a 2-byte address. So for example, if you use the long jump, it requires a 3-byte instructions. This is, we have an opcode and we have a 2 operands. But if you go with this S jump, it occupies only 2 byte because 1 byte is for opcode and another 1 byte is for an address. So that 1 byte is an 8-bit. So 2 power 8 will be a 256. That 256 only we are taking a negative numbers. That's why minus 128 to plus 127. Look at this. This is S jump and next one will be L jump. So S jump we can jump from the location to plus or minus 128 location only. But this is not sufficient for some cases. For example, if you want to jump from 4000 to 5000 or 5000 to 6000, it is not possible from jump using this S jump. So that's why we go for with the L jump. So here L jump, it uses a 3-byte instruction. That's the only problem. It uses a 1 opcode and 2 operand for mentioning that 16-bit address. So this is a long jump. Entire 64 kilobyte we can jump from anywhere to anywhere. So this is the advantage of L jump. So whenever you are using a simple loop within that, we prefer to use S jump. Whenever we are going to jump from a long distance, that is, for example, if we have 1000 locations or 500 locations apart from this, so we need to go with a long jump. But it occupies 3 locations because 1 opcode followed by 2 operands. Another method of jump is A jump. This is absolute jump. So here what we do means entire memory location will be divided into pages. So each page will be have a 2 kilobyte. So entire 64 kilobyte that will be divided by 2 kilobyte pages. That means it have a 32 pages. Each page will have a 2 kilobytes. So within that page only it can jump. So if you take a page 0, so within that 2 kilobyte it can jump anywhere. So here also we use only 1 byte for operand, but we get an address of 11 bit. How it is possible? This actual opcode remaining data, this is a remaining 5 bits data will be used for an address. So that 5 bits plus actual bits, so totally this 11 bits will be used for an addresses. So that's why we can jump up to 2 kilobit, because if you have an 8-bit, 2 power 8 will be a actual 2 power 8 will be 256 only. So but if you go wanted 2 kilobit, we need a 2 power 11 because 2 power 8 will be 256, 2 power 9 will be 512, 2 power 10 will be 1 kilobyte, 2 power 11 only will be a 2 kilobyte. So if we have an 11-bit address only, we can go with the 2 kilobit. How this 11 bit will be achieved? Actually this data bits 8 bits, remaining bits will be taken from an opcode itself. So this will be having remaining data bits. So the problem is within that page only it will be possible to jump. So next page it is not possible to jump. Look at this next one, jump at A plus DPTR. So this is a long index jump. So here what we use means, so we use this DPTR with respect to A. So that means the content present in accumulator will be added with DPTR. So that will be final location. That location will be jumps. For example, DPTR is a 5000. Accumulator is 50 means this 5050 will be added. Now this is becomes a 5050. So jump to 5050 location. This happens here. Thank you.